Good evening, everyone. Welcome to CNCG Kochi online, another online session. So today we have Nihil with us. Nihil is a good friend and all-time colleague. We have worked together on different tools or technologies and same companies. We have very long history in the past. So today he have accepted our invitation to do a session with the CNCG Kochi on open telemetry and observability. Our open standard in observability is open telemetry, and he will be sharing his experience with OpenTelemetry Operator and Beyla, and how we can use them for auto instrument the application to get all the traces and bring more observability to your applications. So, welcome Nikhil to the session. Please, if you can just quickly introduce yourself before starting, that would be awesome.
Thanks, Vishnu. So basically, like from a background perspective, like I'm mostly started as a software engineer, then doing DevOps plus cloud stuff. So right now, stuff is not a limitation. So like I'll be working on multiple, like even application development plus cloud plus DevOps plus SRE things. So that's my day-to-day role. Like I'm doing like mostly from infrastructure, SRE, and DevOps nowadays. Previously, it was like DevOps plus software engineering. So, that's one of the good practices which we are also like building for other companies as well. So, I was part of multiple organizations, now just like doing some kind of like small works here and there for us, contract plus other things. So, got really good experience on working on multiple clouds across multiple regions. So nowadays, like mostly focused on like Google as well as like Azure one. Past couple of months, we were experimenting with OpenTelemetry plus other things as well because when I got introduced to like basically observability, that was like I don't know, like 4 years back. That was introduced by Vishnu also, Vishnu to me. During that time, we did a lot of observability tooling, like we created our own products, our own things. Nowadays, it's got much more mature and standardized. That's where the latest instrumentation that we have done for a couple of customers, we pushed for OpenTelemetry operators. Collectives was pretty much good a couple of years back, but there are new features available in the operator side, as well as Beyla for doing observability. That's where we are. I was also like, okay, we'll take a session on like what are the new things and how we are doing auto instrumentation using the OpenTelemetry operator as well as Beyla. There are pros and cons when you do auto instrumentation using telemetry operator as well as in Beyla. The type of metrics that you are collecting is slightly different. When you're doing manual instrumentation, that's also slightly different on how we will be doing it. So I think we will get started quickly then. Yeah. Yeah. So when it comes to trace, it's a combination of different aspects. So when if somebody is asking what is a trace, trace will be a representation of a single request across multiple services. So if a user is coming and sending a request for login or fetching a piece of information, that information or that particular request can go through your gateways, your front-end services, your back-end services, even through databases. So that a single request across multiple services that will be a trace. And it can have multiple units. So basically spans are like units of work. That can be an HTTP handler. It can be a database query. It can be an RPC call to an external system. Even asynchronous things we can actually make into a trace. Then when it comes to context, that context will be like tying all these spans together. So we'll get multiple spans from multiple systems as like we will be combining all these things to a single context. Then you will have a signals. So basically we'll have the trace, metrics, and logs. When you correlate all these together, you will get like much more full observability side. Today we'll be more focused on how to collect the trace because metrics and logs are pretty much easier to collect. It's basically the correlation between all these three things can be together. You will get a really good signal. The outcome should be like an end-to-end visibility on the latencies, the errors, the dependencies between each services, things like that. Then why we need a tracing? So when it comes to distributed system nowadays, most of the services are distributed. Even when it comes to monolith application, inside there will be distributed service layers which we are writing. But in modern days, like we trying to go into a microservice mode, but since like certain companies are still on like a monolith, those monoliths are architected in a way that it can be easily split into different microservices, so that in case if they want to scale it out, they can just carve out one service and put it differently there. And modern services are a little bit complex when it comes to the microservice or the service architecture which we are following. There are a lot of asynchronous message queuing, process, things like that. So we need a proper trace between if a user is making a request, if it's going to Kafka or any other queuing system, we need to know what is happening end to end. Then tracing shows like where we are spending most of the service time. So if it's a service is not well optimized, we can get to know that okay, database is calling, taking 10 milliseconds, but the backend for parser is taking more than that. Then we will be able to reduce the MTTR, like get to know the bottlenecks as well as the mapped dependencies. That is one of the main things which, when it comes to mapping the dependencies, where basically we will get to know that the interdependency of the services, as well as if any kind of architectural changes that need to be changed there, we should be able to identify it on the dependencies map. Then we can actually like proactively we can do SLA and performance engineering, because when you're collecting the traces, we'll get to know the latency, things like that. And if you noticed from a certain region for those kind of users, if the database latency is getting higher, we will get to know that okay, there is going to be an issue is going to be happening. So we can be actually proactively monitoring those metrics. Then when it comes to the structure, so basically we will have the span structure as well as the context propagation structure. The span structure is basically when you're collecting a span, these are the certain attribute or fields that need to be inside a span. So we'll be having the name, basically the operation, like if it's a get, the endpoint will be there. Then what kind of span it is? Is it a server side, client side, producer, consumer? These things can be changed. Then the timestamp, so basically the start and end time. Then the attributes that can be custom attributes. So let's say if you want to inject some custom attributes like the user ID or the session ID, that can be done on the attribute side of thing. Then the status, if it's an error span, if it's an OK, or if it's an unset one. Then events, so like you can do timestamp annotations on that one. Then links, so if it's depending on any other spans or any other things, you can do the interlinking as well in the span structure. When it comes to context propagation, which is a very crucial piece of data, this data will be used for propagating your context. So consider a scenario where your front-end service got a request, and when you're sending that request to the backend as in synchronous or even an asynchronous call, the backend processing also need to tie to this particular front-end request. So in part of that, we can actually send the trace ID or the span ID with the HTTP header to the backend service, so that we will get to know that okay, it is a continuation of this particular request. This can work across your asynchronous system as well. So if you are sending something to a queuing system like Kafka, Nats, or any other kind of RabbitMQ queue, you can actually set these IDs also part of your message. And when you're consuming it, you can actually continue your trace path with it. And there are formats. So basically, the most common format right nowadays people are using is the W3 trace context format. Then Zipkin is following something called a B3 format. So there are different format, but nowadays most of the people are start using the W3C trace context and OpenTelemetry formats. Okay. Then when it comes to like an advantages of when you are doing a distributed tracing, obviously we'll get an end-to-end visibility across all the services. Then we'll get to know faster diagnostics and we can reduce the MTTR, bottleneck identification and capacity planning. So for each services, we will get to know how many loads or how many users interact with it, and we should be able to do a proper capacity planning as well as with it. Then basically one of the main one is like a dependency mapping and architectural rationalization. So when we are architecting a big microservices, which is like 100 or 200 services, there are flows which will come to microservices. When we do a visualization of this particular tracing, we'll get to know that which are the systems interacting with each other. And if we found, okay, a system is highly dependent on another system, then it makes sense to combine those systems or like distribute more evenly, then we can actually find any circular dependency or circular calling happening. Then you can obviously do a logs and metrics correlation. So for a trace, you can actually pull in the actual number of logs associated with it or metrics during that particular time. There are challenges. So when it comes to tracing, there are main challenges will be your overhead. So CPU, memory, and as well as your IO, because you are sending network traffic across it. Then the data volume. When it comes to production systems, the most recommended approach is basically to disable tracing and just enable it when it's needed. So a couple of e-commerce website where we are doing tracing, where what we have is basically we have a toggle switch kind of a feature that we have baked in. So in case if we need tracing and if we found there are certain issues, what we will do is like we'll enable it. We'll collect all the trace metrics logs and we'll do correlation. Then when we are doing a new release, we will enable the system for 2 to 3 days. Then we'll observe if everything is normal, we'll disable it because it's basically to just save the cost as well as the performance side. We have noticed, like especially for Magento, PHP Magento, we have noticed like when we disable all the tracing and metrics, we were able to get around like 100 to 200 millisecond more performance. So those kind of scenarios, we'll just make it as a toggle one. Then sampling. So basically, when you're doing tracing, it's not advised to keep all the traces because you are going to hit a lot of data really quick. So usually we will do a sampling rate. So 1 in a 10 or like half the rate, we will try to do a sampling. Initially, it's advised to gather all the data. Then once you fine tune the system, you can actually start you can write filters saying that if it's taking more time or if it's an error span, then only store the data. Then the main one is like cross language interoperability, basically cross framework. So if you have certain services in Go and there are certain languages in Java, you need to make sure that your libraries or the auto instrumentation will pick up those framework properly. And the trace also is more, like propagating properly. Then the other ones is basically the asynchronous stuff. So basically asynchronous, or if you're running some batch jobs and your attribute hygiene, that is something really important. Basically, when it comes to a format, you can inject custom attribute. One of the main custom attribute that we see uh, most of the business inject will be the user ID and the session ID for tracking the user sessions. Those are good to have features, but when developers start injecting all the attributes like the user address or certain things, then your span will become bigger and bigger, which will make like your data volume also go up, as well as the searching will also go down, like search speed. So it's good to have a proper attribute hygiene. So collect only the data that you need, only inject the data what is a must on a particular trace. Then when it comes to adaptive sampling, it's really good. So you are just collecting only the error rates, or if a latency is going beyond a threshold, you are only collecting those kind of traces. Okay. So when it comes to approaches, you have your manual as well as the automatic one. So basically, like let's say from a comparison side, let's say from a control and flexibility side of thing, from if you do manual instrumentation, that means you are injecting the libraries directly onto the code. You will get a full control as well as you will get a custom spans. So let's say if you want to create for a block alone, so instead of instrumenting a function, you can actually instrument a block of code itself. So you know that okay, your parser code is having some issues. So you can actually wrap around a particular span on that particular function or block of code. So you'll get a more control there. When it comes to automatic ones, you will miss a lot of custom logics over there because it will go function by function or service by service. Then when it comes to business context, okay, like from a manual instrumentation perspective, you can actually like really dig into the business logics and you can actually export the custom logics or custom attribute from your business logic to the traces. But when it comes to automatic instrumentation, those features are missing because you are depending on your automatic library to pick up the logic, and it will miss actually the business context because it's mostly framework driven. Then when it comes to development effort, obviously the manual instrumentation will have higher like dev effort because you are doing the code change as well as it need to be properly reviewed. You need to check your trace if you're handing off your traces ID properly to all the systems. Automated instrumentation, it's basically it's not even like from developer side, there's not much anything needed. From infrastructure side, we should be able to deploy the tools and do auto instrumentation. Framework coverage is the other one. Basically, there are restrictions when it comes to if you're doing a manual instrumentation, you need to check the library as well as the library versions. These kind of limitations are there, which is notorious when it comes to platform side of things. So if you are using New Relic or Datadog for collecting the traces, the libraries version should match with the framework version as well. When it comes to auto instrumentation, it's mostly it's like it's wider range is covered. Then runtime overhead, when it comes to manual instrumentation, it's very not very less, but it's you can still it's manageable. It will be like less than 2% or 5%. But when it comes to automatic instrumentation, you have increased startup and runtime overhead. The reason for that is basically when you do auto instrumentation, the platform will try to inject some kind of library or some kind of middleware on top of your application code. So if you have an application which is a Java application, and in your Docker file, if you're writing Java minus jar for starting that particular Java application, when you do auto instrumentation, what the auto instrumentation tool does is basically it will identify if it's a Java application, then it will inject a library on front of your actual code, actual application. So it will be doing like in Node.js kind of thing. It will be Node app.js. It will inject Node requires a certain instrumentation library. Then only it will call your application. So all the function call plus all the HTTP call happening in your application will go through this middle layer. So in order to get those set up, you will have your overhead plus your startup time will increase. It's better to have a hybrid approach. So for business critical applications, it's mostly good that if you are doing a manual instrumentation, then certain low hanging fruits, you can start with the automatic instrumentation. Okay. And when like we don't need instrumentation for the entire application. So one of the main mistakes that we have seen most of the customer do is they will install Beyla or they will start instrumenting everything or the application. Then it's the SRE team will come and start checking, okay, we don't need these data. So a good approach is to identify your critical user journey, basically your authentication, checkouts, payment, things like that, then start with those things. So you'll start instrumenting those kind of services, then you can like point across, because there are certain services you don't need to even like instrument it. Then you need to define your network boundaries. So basically in which layer that you need to stop it. So basically that's your HTTP clients or the servers as well as the message queues. So if it's a third party one, you might need to instrument those kind of services which is talking to outside. Basically it will have its own failure rates. Then when it comes to data stores, mostly from application side, you can do instrumentations on the queries and caches, but database will have its own logging mechanism, which will give us like some more insights into the query execution, things like that. Then expensive functions and external calls, those are like a very good place to start with your tracing. Then basically your arrays, exception, high latency path, things like that. So if you notice something for a particular endpoint, the latency or the exception rate is very high, we can actually start instrumenting those particular services, then go from there. Then the one of the most adopted frameworks or the formats right now is basically the OpenTelemetry protocol. So it's a standardized way of collecting the data as well as sending the data. OpenTelemetry protocol will can like collect as well as work with traces, logs, and metrics. So it can process all three of them. I think for heat maps and things like that, they are still working on it for the browser-based ones. So those things are still not worked on, but mostly OpenTelemetry collectors are really good and a vendor-neutral one which you can use. So we always suggest for any customer, even if they are really tagged to a particular observability vendor, we still suggest them to go with an OpenTelemetry collector in between, so that we can actually send to multiple places or we can inject custom attributes to the traces. When I'm saying custom attributes, one of the example is when you do, uh, let's say multi-tenant cluster. One of the example is we done an implementation on a huge Kubernetes, multi-tenant Kubernetes, where we have divided, like we have grouped each team or each application into a tenant or a project. So they will have a list of namespaces. Between those namespaces, the network is allowed, as well as uh, basically they can do authentication to that one. Then when we are collecting the metrics from Prometheus, we are checking if that particular metrics has any namespace attribute. If it has a namespace attribute, that means that particular metrics is tied to a pod or a workload. If it doesn't have a namespace, then it means that it is coming from node or from cluster level. And when you are sending to Grafana, we are actually putting the Xscope org ID to segregate these metrics into different tenants. Then in Grafana, as a team A, if I come in, I will automatically create a data source with those particular parameters so that he can only access or he can only see the metrics which belongs to his namespaces. But from a collection point of view, we are collecting a single metrics from all the cluster, then we are segregating it. So those kind of things is really good in OpenTelemetry. You can like be creative with the OpenTelemetry ones. Then it will automatically handle the performance, like the overhead and the back pressure retry mechanism. So we don't need, so the client libraries does not need to handle those kind of things. Then it supports like protobuf schemas, things like that. So version changes, it will automatically detect, and not automatically, but basically you will have control on top of those kind of schemas. It's basically the data model is similar to a
Nihil,
JSON one, but
um, sorry to interrupt. Like we have one question from Lakshman. So do you want to take that up now or maybe later?
yeah,
If
we can take it now itself. So yeah, so basically how we were doing that, where like for that service which I mentioned, how we were doing was basically we had a like init wrapper on top of the actual container service where we were passing some kind of environment variables. So in that environment variables, if I'm making true, we are actually doing a switch case there itself. It will restart your application pod, but since it was a Magento stateless one, it was doing a horizontal scaling. So we had 20 of them. So and we had a PDB, so it will do one by one. I can just go and I can say that okay, start collecting the data. It will automatically restart with that particular environment variable. Then it will inject the library in front of that particular actual application code. So that's how we were doing it for that particular customer. Uh, yeah. And I have seen certain places where they were trying to do some kind of web-based, like click-based one, but that was like too much overhead on top of that. Yeah. And like OTLP data models, it's just basically a JSON structure which is going there. So I think we can see that separately. Then when it comes to why we need to use an OpenTelemetry collector, it's basically all the benefits that we are getting. It's basically central and it's vendor agnostic. And most of the modern tools has it. Like even if you go to any new LLM tools based inference engine, those has an OpenTelemetry exporter which they will give us. So it's like a standard that we can actually do it. Then basically we are decoupling the apps from the actual credentials to the our storage systems like even Grafana Tempo or New Relic or those kind of system. Then we are doing retrying and buffering. So even if the target system is down, your library or the application does not need to like store that traces. It can offload that to OpenTelemetry collector. It does that one. Basically route to multiple backends. That's one good thing. So basically, if you want to try out a new observability system, you can just like add the new backend systems there. So it will send to multiple destinations. PI redaction, so any email IDs, things like that, that you can do. You can emit from like you can like pull out those information. You can like mask it or you can just remove it. Then character attributes are there. So like the is it a daemon side deployment, things like that also is there. Then we can do tail sampling and like mostly the data collection efficiency. So those kind of things are also there where you can optimize it how you want to collect it. You want to do centralized one or things like that, which we can see from the demo. So this will take into the demo itself. Then basically we have the different collector deployment patterns actually. So when it comes to open telemetry, we can deploy it into as an agent. So that will be a sidecar or as a daemon, it will be running. It will be running on each nodes. Then you can actually deploy at a gateway deployment level. That's which is most people start with gateway or deployment method where you have a deployment of your OpenTelemetry collector itself, not even the operator, just the collector. Then from the collector, you will start sending the data. From there, you can actually send to multiple destination which you want. There are pros or cons for both of them. So it depends on your environment scale, how you want to do it. So I'm not, yeah. So basically, right now we will go into OpenTelemetry Operator on how we can do implement it. So basically, when it comes to OpenTelemetry Operator, we'll just directly go to demo itself. So for installing OpenTelemetry Operator, the first thing is basically like Sub Manager need to be there. Even if it's not there, there is a mode on OpenTelemetry Operator where you can just deploy the operator without the Sub Manager. But basically, when it comes to OpenTelemetry Operator, there is not much things that need to be customized. So basically, you can get the chart or the YAML file, and you can just directly do the Helm installation. Yeah, and we are not changing any values. So this is the stock chart. I haven't changed any image or anything. I just like install the OpenTelemetry Operator, and it will be running on OpenTelemetry operator system. You can actually see the OpenTelemetry Operator running there. Once the OpenTelemetry Operator start running, then what you can do is like you can actually start deploying the collectors. So these are the actual OpenTelemetry collector which is getting deployed. One of the example of the collector is basically this particular piece of collector. The initial ones are the service accounts, which I'm just like giving some permission to that OpenTelemetry collector so that it can pull the attributes from Kubernetes and just inject onto our traces like namespaces, things like that. Then this is actually one of your OpenTelemetry collector. So in the collector configuration, this will be your OpenTelemetry configuration, which we usually does. So in the configuration, we are actually saying what are the exporters we have. So right now I have two exporters. One is the debug exporter just for logging and seeing what is happening there. The second exporter which I have is actually to OTLP HTTP. That means it's an OpenTelemetry based one. This is just a name. So this, it doesn't matter like this. Even I can just like put ABCXYZ. It's just a name identifier there. But for now, I'm sending the data to Grafana Cloud. So, and I'm sending in OTLP format. So it's actually I'm sending to Grafana Cloud's OTLP collector with the like my credentials. So it's this particular will have my like account ID plus one of my API tokens. That's it. Then when it comes to processes, these are the processes which I'm using. So I'm using a batch processor to just batch the entire request together so that when it sends the data, it sends as a bulk instead of like one by one. And the other one is like KTS attributes. So this particular process, what it does is basically to identify the all the namespace deployment things like that, and inject all these Kubernetes attributes to the particular span or the metrics. Then when it comes to actual attributes, I'm actually I'm changing the name a little bit. So instead of like kts.namespace.name, I'm actually like putting the name itself. So I'm just like relabeling it. So instead of like if you want to search it, you don't need to search kts.namespace.name. You can actually do like namespace itself, and you can be creative with it. I think there is a it supports some kind of regex plus the formation there, so you can actually combine two to three names together to create a custom attribute as well. Then memory limiter just to optimize stuff. Then receivers. So these are the receivers for the OpenTelemetry collector where I am listening for OpenTelemetry based data on 4317. That's a gRPC protocol. So if the client want to send it into gRPC, they do 4317, 4318, our normal HTTP one. So this is our normal pipeline. So the above you are actually defining the receivers. So that's your input. Then you have your exporters, that's your output. Then you have your processors. So that's something which you want to do in between. So the actual pipeline will look something like this, where for metrics, I'm getting the metrics from OTLP metrics, like OTLP receivers. Then I will add these particular processes in between. Then I'm sending to debug, and as well as I'm sending to the Grafana Cloud in OTLP format. And same for the tracers. So right now, this particular collector has the ability to get the data for trace, metrics, as well as logs. but we are only sending metrics and trace to an external system. And telemetry, I'm just like listening on it. I'm not doing anything on the telemetry side of things. And so this will be your trace collector. So let's, if I want to deploy, let me do one thing. Let me, I'm just like deleting that one. So now I can do is like, I'm going to create that particular collector. Okay, so this collector is actually a standalone collector. So you don't need an operator. So if you are using an operator, then your kind will be OpenTelemetry collector. But you can simply create a deployment with OpenTelemetry like a container, and you can just like put the configuration as a config map or inject it there. This exact same configuration will work. But for auto instrumentation features, we need the OpenTelemetry collector. So now I have an OpenTelemetry collector running there, which is actually used for collecting the trace. OpenTelemetry operator has an auto instrumentation feature where we can do auto instrumentation for an application. For that, I just created a sample like a Node.js small application where we can actually just do some traces. So if I do and start, I guess. Yeah, so I can just do care localhost 3000. It has some endpoints like some API/orders or some usage endpoints. So for this application, we want to do auto instrumentation. So as part of auto instrumentation, the first thing which I'm going to create, so all these OpenTelemetry collector as well as the operator, these are running on OpenTelemetry operator system. The application, there's an application which I'm going to deploy the same application. So this I'm going to create it in OpenTelemetry demo application. I think it's already there, but let me check. Yeah, I think the application is already there. Then for creating the auto instrumentation, there is a file called instrumentation. So in the instrumentation itself, we can actually mention which exporter to use. So you consider this instrumentation as your profiles. So you can actually create multiple profiles for your instrumentation. Then you can attach to the workload that you want. So for now, what I'm going to do is basically I'm saying that, okay, this is like a default instrumentation profile. All the data coming to this instrumentation will go to our particular collector. So you can have multiple collectors, and depending on multiple instrumentation, then you can do mapping. Like, okay, if I'm getting in this particular instrumentation, send to this particular collector or a separate collector. Then basically I'm just like giving as a name OpenTelemetry collector demo. So this will make sure that we'll identify the service name. Then basically some attributes. I'm just like putting in the service version. That's it. Now what I will do is like I can just like create this instrumentation. So this instrumentation I'm creating the same namespace as our application namespace. Okay. Then what I will do is like I can just go to my deployment file, and in deployment I will add these two annotations. So these two annotations are added to the ports, not to the deployment. So when you are adding these instrumentation, you need to make sure that it's actually attached to the ports. And you can actually see instead of putting it here, I'm putting it in the template inside itself. And this particular instrumentation tells that, okay, we are going to do an auto instrumentation, and we are saying that it's a Node.js application. So it's like a Node.js. For OpenTelemetry collector, the languages are limited. So you can do inject on, I believe, .NET, Java, Node.js, Python. There are limitations when it comes to Go or other languages. So right now we'll do inject Node.js because it's a Node.js application. And if you want, you can actually whitelist your container names. So if you have multiple containers as part of your single port, you can actually see that, okay, do it on the app itself, app container. So that's basically matches with here. Now once I done that one, I can just do, I'll just like do the change. So I can do get port demo. Okay, you can actually see it is actually doing an initialization. Okay, so what I can do is like, let's see if I can. Okay, I think it's gone. So one of, let me just Okay, so if you describe the pod and check, so like let's say when it comes to our deployment file, you can actually see it's a simple deployment. We have a single container. There is no init container. There is no sidecar. There's nothing there. It's a simple application. But once you enable the auto instrumentation, if you check, if you describe and check, you can actually see there is an init container which was injected by our OpenTelemetry collector. So you can actually see it's actually doing OpenTelemetry auto instrumentation, Node.js. It will pull in its own images. Then it will actually do a mounting and it will start it. And you can actually see there are certain variables it was injected by that particular init container, as well as you can actually see the logs also changed. So what it will do is like it will inject a library in front of your application. So if I do uh, no. Yeah, actually that one is not here. So usually what it does is basically if it detects Node.js, it will inject a library in front of your actual application code. So that's how it will actually put in your library file there. And sometimes if you're using Java application or something, if you go to the pod and do just like do a PS and if you list down the process, sometimes you will be able to see what it does on front of it actually. So now what I can do is like I can just like how why localhost 3000 is working is basically I have a port forwarding running. So I'm actually using Rancher desktop. So in the Rancher desktop, let's do one thing. Let me, yeah, I'll just like for that application, I'm just like forwarding the 4 to 3000 to my local so that I will get. So then I can do. Let me do this one. So I'm just running a bash script to just generate some loads and to check spans actually. So right now, what we are doing is like we are sending the data to Grafana itself instead of any Tempo or something. So I'm using Grafana Cloud. If I go to explore and if I go to my Tempo, I should be able to start seeing some spans. Before that, we'll just check the logs. Okay, logs. Yeah, you can. So we are putting debugging. That's the reason why these things are pending. So I can see, okay, like there are requests coming in here. So our OpenTelemetry collector now receives the data from our auto instrumented application. So right now, if you think about it, from our application side, we haven't done anything. The only two pieces of information which we added to application is basically these two lines on the annotation side. Then we have created an instrumentation. So how does the mapping work is basically the instrumentation name is default. And in the application itself, we are actually saying that use the default profile. Okay, you can actually see default here. Then we are saying that basically for this particular container, take it. I just disable liveness and readiness performance like I was just getting constant traces. So now if I do for last, usually it needs some little bit while to get it done. I'll just like start sending some more data because it does the batching from the collector side, then it will go to Grafana Cloud, then the indexing on Grafana Cloud may take some time. If it's a local one, usually Tempo, it's pretty much available really quick. That's yeah. Meanwhile, if anyone has any doubts, I can just take the question. This last time also it took around like 4 to 5 minutes to come up here.
Yeah, I think we had covered a lot in past 30, almost 40 minutes.
Yeah.
So if we have like, and if anyone have any questions, please raise it in the chat. We can just discuss on that while we wait for the traces to come up in the Grafana cloud. So I think one thing that we should emphasize here, right, Nihil, like the observability, the pillars of observability, traces, metrics, logs, right, and how their nature. Like we talked a lot about traces today, so I think we
Yeah.
should also talk a bit more about the nature of the traces, like how it is compared to metrics or logs in terms of volume, right? Uh,
Yes, yes.
and the data that it might send, and how the platform should be ready or available to have, like, to receive all that new addition in traces, right?
Yeah,
So
yes. So,
yeah,
yeah, sorry.
yeah,
So when it
please.
comes to, yeah, so when it comes to tracing side itself, basically, trace is something which tie your logs, metrics, and everything together. So when you do logging, you are just like directly dumping the logs to a particular log file or your logging system. Then you have metrics associated with that particular system, but we don't know for which user or from a which flow that particular logs or metrics is generated. So one good example, like in old days, what we used to do is like we start printing the trace ID or the session ID with the particular uh, logs itself, so that we can identify, okay, from this particular user from this session these are created. But when you do span trace on top of it, we don't need to do expensive operations like that, because when you do things like that, then your login system need to be very huge. Basically, even in case of ELK, that searching need to be powerful. But when we are segregating it, your trace is actually a structured data, your metrics is a structured data, your logs, in a way, it's a structured data. And like if you are doing a standardized log4j formatting or something, to an extent, it's structured data. So when you are storing structured data on modern tools like a time series kind of databases, or even the databases used by the Prometheus, or else even for the Tempo, it's using a proper algorithm so that the data volume will be higher, but the way that it stores the data is very like optimized, so that you are not actually paying lot for your storage side from side itself. Then you can actually tie all these things together actually. So when you are tying all these things together, there you can actually set, okay, I can see some traces coming here. Then from a trace, I will identify, okay, this is my trace. Okay, in this trace, if I want to get the associated logs, I can just click on that particular trace ID and it can correlate with the traces. So right now in our example, what we are right now doing is like right now we are only collecting the traces. We are actually not collecting the metrics. But in the next example for Beyla, we will collect the metrics as well as the trace, but the logging is will not be there. So right now, if you see the traces, we can actually see all the traces coming in, the service name, the actual name of the endpoints, things like that, that's there. Then if I'm opening the slash users, you can actually see what is happening for that particular slash users. So for this particular call, we have a middleware, then we have the request handler, then you have the two other middlewares for doing stuff. So it's basically these are just functions. So you can actually see for the middleware, it's actually only taking 33, I think this is microseconds. Then you have the traces for the other ones actually. So you can actually see logs for this span. So if you configured everything properly, right now we are not doing log collection, but if you configure everything properly, what it does is basically it can, for that particular time period, it can go and get the logs from your Loki or any other systems. Then you can actually see for these traces what are the logs happening in from your system itself. So it's something which tie all of your like metrics as well as logs together. So right now, these entire one, we are actually getting it. One thing which we need to keep in mind, the data that we are going to get from the Bela is different, somewhat different than the data that we are going to get it from the instrumentations, like OpenTelemetry Auto Instrumentation. So you can actually see the traces are coming here. What I will do is like I'm just going to disable all these stuff so that I'm going to, okay. So for OpenTelemetry Operator, this is the way to do it. So for OpenTelemetry Operator auto instrumentation, the first thing is basically you will deploy the operator. The second one is like you will create a trace collector. So the trace collector is responsible for collecting the data, and this is the piece of one which will deploy to, it will push your data to the target system. It can be a self-hosted Tempo, New Relic, Datadog, even Grafana Cloud, anything. Then this is particular mode. So you can do daemon set. When you do daemon set, it will deploy an instance of that collector on each of your nodes. So if you are having a very high scale application or high throughput application, you can do daemon set so that your applications, like you are not overwhelming your network. So if the application is running on node 1 and the traces for that particular node 1 will only send to the collector in the node 1 itself, which will do batching. It will send to the target system. So like that particular traffic is actually not going node to node. It's actually application to the same node having the collector. From there it is going outside. When you do deployment, the problem is like it all depends on where your actual collector is port running. So that can go across your nodes, which can in certain cases it depends on your network configuration or even your scale. That can be an overhead, but most of the cases it won't be an overhead. Then what you will do is like you will create profiles. So instrumentation you can consider as your profiles. You will say that okay, this is the service name. So this service name you can actually get it from here. So you can actually see Option Collector demo. Then your span name. So if I want to get it only for middleware queries, I should be able to get. Then if I want to check any errors are there, I should be able to see that as well. There's no errors. Okay, then you can filter by span time as well. So this is something which I'm saying that when we were talking about the adaptive uh, trace collection, you can actually do in the OpenTelemetry collector itself. In the attribute, you can actually say that okay, if the span is greater than this one, then only save the particular span, or else just drop it because we don't want a unwanted data. So these attribute can use for tracing as well. Then I think this has certain tags which we should be able to use it for other kind of filtering as well. Okay. Then what you'll do is like you will just go to your application, you'll just check. You can actually do inject this one. So when it comes to OpenTelemetry, let's do auto instrumentation. There are language supports there basically. So you can actually see it's only for .NET. Do you know? I think Go, this is a newer one because a couple of months when we were trying, the Go one was not there. Java, Node.js, Python, and other libraries. So if you are using any other kind of languages, it will not be supported there. But I think it's mostly there. I think Rust or something is not there. Okay. Now we will move to the Beyla side of things. So right now you can do it. So if your tech stack is only between them, you can actually start with this particular one itself. Okay, so this is basically your CRDs and like their corresponding responsibility. So you have the OpenTelemetry collector, which will deploy your collectors one actually. Then the instrumentation CRD that specific to your particular application, what is the name, things like that. Basically, the operator will watch these two CRDs and it will actually deploy these stuff. So if you are uh, adding annotations to any particular ports, it will automatically pick the corresponding instrumentation libraries needed and it will inject in front of it. Okay, the installation we just talked about. Yeah, operator features. Basically, deployment modes you can do sidecar like daemon set deployments or stateful set. Then you can do target allocator for Prometheus scraping. So that will give you some more control. Then you can do enrichment. So that's where I was telling that, okay, you can do custom attributes here on the OpenTelemetry collector itself. Oh, sorry, where is the collector itself? So you can actually create something like, okay, tenant or team, which will like it will be a combination of your namespace name plus like some other particular attribute like a label from the namespace level which you can pull in that particular information one. So how we were doing this one was basically we were appending the namespace name with the cluster name. So we will do namespace name hyphen the dev cluster stuff like that. Then we were doing the batching on top of the tenants. Okay. Then you can do, sorry, you can do multi-instrumentation. So you can actually do like container-based or language-based instrumentation you should be able to do. Yeah, then sidecar, that's the one which we now have seen. Basically, we are injecting using the annotations. These things we already have gone through that one. So basically, these are the supported languages, and they are how we should be able to do it from there. Environment configuration, these all things are auto-injected when you do auto-instrumentation. Okay. Then these are certain, the way that you can do troubleshooting is basically the first you need to check is once you do labeling, once you restart it, and if you're not seeing that init pod container spinning up, then that means it is not picking up properly. Then the collector logs, you should be able to check it. Then it's basically the mapping. It says basically we are saying that once you do auto injection, send the data to this particular collector. If the collector is not getting the data, that means it's an issue with the instrumentation. Then if the instrumentation is good, you can actually check the port. If it's the init containers are not created, then it's actually not picking up. So there could be some namespace kind of filtering there. Okay. So yes, the pros and cons is basically you don't need to do any code modification. It's easy to manage. It's backend integration. It's directly OTLP backend. You can do enrichment as well. I will quickly go to the Beyla implementation side itself. So right now, Beyla also will use the same approach where we are actually using OpenTelemetry collector, but we will not be using the auto injection feature from the OpenTelemetry collector. So right now, I can do, yeah. So right now I have the applications running and I will be doing the Beyla based instrumentation. So what we are using the Beyla is Beyla will do the instrumentation on your application, get the data on OTLP format, send it to our OpenTelemetry collector, which will be reusing. So for Beyla, it's same. I'm using Helium values for it. I'm not changing anything apart from the configuration on the data discovery side. So what I'm doing is like basically I'm actually saying that okay, only do instrumentation as well as service discovery on these two names, this namespace because Beyla works using eBPF. So it is actually directly plugging into your kernel. We have seen issues with Beyla with the other language libraries. So one of the major issues that we have seen in the past couple of months is when we does Beyla, Beyla is interacting with certain library versions in Go application where Beyla is actually forcefully killing that application. So the behavior was basically the application was running, it was serving the traffic. Once we enable the Beyla, the moment that particular Go service was getting any HTTP request, that HTTP server was getting killed. Some panic was happening on the kernel level. The pod was not crashing. So we were not able to figure it out. Then we understood from the kernel traces and everything. Okay, Beyla's process is interacting with that one. So it's good to when you're doing Beyla, just make sure that you are like targeting the namespace or the application because we don't want to do the cluster wide, which can create certain issues. I believe those are patched now, but still, when you're doing Beyla, just be mindful of those kind of things. It's not only the Beyla that can crash. There will be some impact on your application as well if there are certain props which is reused by the application as well as your one. One of the main example is the if you are using Argo CD, Argo CD has an authentication component called DEX. DEX does not usually play well with Beyla. I'm not sure if it's patched or not. We observed this issue with DEX crashing when we were using Beyla. That was like 2 to 3 months back. The other ones, these are like default Beyla configuration. The only things which I have added is this basically these two lines. So I'm telling to Beyla if Beyla is collecting any metrics, send it to our OpenTelemetry collector. As well as same, if it's collecting traces, send to our OpenTelemetry collector. And I'm doing instrumentation for all. I can do install Beyla. I'm just okay. Sorry, the problem is okay. So right now I'm deploying Beyla. Beyla usually runs as a daemon set, so it will go and create a pod on all of your uh, all of your nodes. So it's running as a daemon set. You can actually see I just have a single node. So that's the reason why I'm only seeing one. I should be able to check the Beyla logs and it should be working fine. So right now it can actually start, it will actually start collecting the data from our application. In this way, you don't need to even restart your application. It will directly go to the kernel and it will start it. So our application is running, uh, yeah, this is actually running for last 11 minutes. We just deployed Beyla. I'll just create some more log bash minus C. Okay. Now, if I go to the way that you can distinguish between the logs sent by Beyla as well as OpenTelemetry collector, I think in Beyla, the service name I have configured is OpenTelemetry demo. So I believe that's the name I should be seeing now. Yeah, anyway, okay, I'll do. Yeah, this is the demo one. We should be able to check the logs from OpenTelemetry collector, and we should be able to, yeah. So yeah, actually the collector is getting the logs from Beyla. So right now, the collector is the same. We just changed the input. So we are collecting from the Beyla one. Since Beyla is using eBPF, there are other certain kind of metrics that we will be getting. So one of those metrics will be the wait times. So I'm just waiting for the new trace to show up here. Yeah, you can actually see the new metrics are happening here. So you can actually see the collector demo is there. Then if I do OpenTelemetry demo, so these are the spans which is sent by our Beyla, collected by Beyla. And if you can actually see, the data which we are seeing is slightly different. So in case of auto instrumentation, we were getting the data directly from the code itself. So we will be getting to know. I can do one side-by-side comparison. So that's one metric. So if I change to okay, so this one. So if you check on this particular collector one, you can actually see we are getting the call from each each function by function. We are getting to know what is happening there. But when we are collecting using the Beyla, the problem will be simulate. I think simulate itself. We can actually see it is actually not showing the function breakdown because it is actually getting it from the kernel level. So it depends on your language. I think since it's Node.js, it's actually not doing much of the things there. But if it's Java or some other application, you will get to know more things. One of the main metrics which eBPF will give, like from eBPF will give you something called in queue one. So this is a metrics where your request came to the system and the request is waiting for your application to pick up and process it. So it's just like queuing time or your thread is blocked, things like that. So this metrics you are only getting using the eBPF. You will not see these metrics from their side. So you can actually see, okay, I'm getting the metrics in queue, like it's like 1.5 milliseconds, then the actual processing is happening there. So this is also auto
With the
instrumentation
mail,
in this
you
way.
mean to say like the other external calls or DB query time and all that we will not get.
Yes, those kind of codes, it's very, so sometimes it shows up. So what I found was like when you do instrumentation like Go or it's mostly the language and process perspective. Sometimes we were able to see it, but sometimes we were not able to see it. So the Bela is not a really good example of if you want a like in-depth code based one, it is actually not giving you much of the things. I think for certain languages and same certain frameworks, it is actually giving you something one. So that's there is like when you should use it that like I think I have put it in the slide like when clearly you should use beta one. Then I am actually collecting the metrics as well. So when you're collecting using Beyla, it is actually giving and pulling the metrics as well. So I can actually see, okay, for OpenTelemetry demo, like these are the endpoints and these are the, I'm not sure why it's showing minutes. I think it should be, yeah, milliseconds only. Then I can see the duration, request rate, things like that. So this metrics also is collected, like it's generated by Beyla, collected by the open telemetry collector and sent to our Prometheus. So it's actually stored in the Prometheus side itself. Okay. So that's from the Beyla side. I will just like quickly go through the slide, these things we have done there. So basically, from a Beyla architecture perspective, we will have the eBPF usual stuff. So we will have the a process which will does the kprobe and uprobe to listen to all the network calls. Then it will do the transit inspection. Then it can do trace. It will create the metrics and the span. Then that will be sent to the OpenTelemetry based collector for the spans and Prometheus for the metrics. Then you can do enrichment on top of it. These things
Nikhil, we
are
have two
fine.
questions. One
Yep.
from Lak, like is in eBPF is uh, solved saying it won't cause kernel panic. I meant like, yeah, previously we used to write kernel modules for different versions to support or extend the kernel features, right? So since CBPF supposed to run in the user space, it shouldn't cause kernel panic. So that's his question.
Yes, so it was not a panic one. So we didn't done a proper like what you can say RC on that one also. When we were checking the log, we could identify that the log which it was emitting, it looks similar to an eBPF one. So then we understood, okay, the eBPF based application running on that cluster is a Beyla, and it was a centralized separate cluster that eBPF should not be running there like from the day one itself. So that's the reason why we moved it from there. Actually, it should not do that. So basically, it from an eBPF level itself, if it's doing some like if it's inspecting the traffic, actually it will only collect it. It should not interfere with the network itself actually. But the behavior which we saw was slightly different over there. It was only for that particular process. It was only for Argo City text itself. Then, so it should not, but we have not done a proper analysis on why it was happening there. I need to check if there is any GitHub issue open for the same thing or not. Yep. And when it comes to the Beyla resource utilization, it is little bit on the higher side, but not too much overhead. So even if you do any kind of resource-based utilization, like if you're collecting any metrics or anything, it will be higher on the side, but not too much. Uh, I believe the CPU utilization is higher when it comes to Bela 1. I have seen around 10 to 15% in certain cases, but low was like 2 to 3% as well overhead. The When it comes to the Bela's performance as well as limitation ones, it's basically mostly it's low overhead. As we mentioned, it's just listening to the couple of probes on the kernel side itself, so it should be lower. But the requirements are there. So you need to have a kernel 8.5, like 5.8 or higher with the BTF ones actually. So the props need to be there. Then the capabilities. So when it comes to the kernel, you need to have the cap BPF or perf capabilities, and the netadmin one is there actually. Bela will only give you some generic spans as we discussed and as we saw. If you want a language based one, you need to go something different. Get a service to service calls. Yes, we will get actually a service to service Bela instrumentation also we will get because it can identify the traffic and it can do it. But it lacks when it comes to what kind of application that we are using. Mostly it with language specific actually, to be honest with you. Okay. So one of the use case when to use Bela is basically let's say you have a service where you don't have access to the source code, or if it's a vendor application, you don't have any observability there, and if it's a very legacy application. So in that case, you don't know what is happening there. So for those kind of application, just to get some insight, we can start with Bela so that we will get to know that, okay, what is that particular application doing? What are the codes happening there? So for legacy application, we should be able to start with Bela and get some information out of it. Then once you go more in depth to your own application, your own codes, then we can actually look into like OpenTelemetry based instrumentation, where we are injecting the library, which will give you more like proper insights there. Uh, yes, I think we are almost, yeah, we are well past the time. So I'm just like, uh, just going through the scenarios. Basically, if it's a greenfield one, it's good to start with the Beyla itself for most of the time. For third-party libraries, Beyla works better because you don't have a control there, but you can do a lot of things. If you need like in-depth business spans, then like OpenTelemetry Operator will be better because it can go code level and function level and get information. Since Beyla is only on the network and API level visibility only. Then the privilege one, I think it's basically Beyla need like more control and more privileges there. Then the cluster-wide visibility, like Beyla is excellent at it because it is actually plugged into everywhere. But OpenTelemetry Operator, we need to like onboard edge namespace one. Non-KTS host. So if you have some Docker or host machine, Beyla can still work on Docker host or even like a Linux-based machine itself where OpenTelemetry connector cannot work there. It's an Kubernetes only solution. We can combine it. So like certain applications, we can use Beyla for collecting it, and certain application we can actually use OpenTelemetry based one. Okay. So yeah, you can do reference architecture on like how we certain application you can actually do like as we discussed, you can actually do OpenTelemetry based auto instrumentation or Beyla itself. I think, yeah, these are the best practices that you should be following. So basically, do the sampling. Don't collect all the information. You don't need those much. Like for logs, metrics, as well as for traces, you don't need all the information. Uh, Metrics by default, it does it. So when you do Prometheus, it is actually not collecting all the metrics point. It's basically according to a scraping period only it will collect the data. But for logs and metrics, make sure that you are doing a like you are collecting everything, then you are actually filtering out unwanted logs and you are only storing the errors and slow based ones. Then make sure that you are doing attribute hygiene. That means we can inject multiple attributes as part of your span, but don't overdo it. Then basically make sure that all your connectivity between all your characters and everything is actually TLS based. It's by default available. You can just enable it. Then versioning. So basically all the versions, your agents, collector, SDK, these are matching because version to version, there are schema changes happening there. Then make sure that you are setting the proper attributes for the service name, the versions, the environments, things like that. Yeah, I think that should be fine. If any doubts are there, you can let me know. We can discuss this. Yes, as Lack mentioned, back in the days, we use S-trace for finding out lot of systems like that. eBPF will also do something similar to that one, but not to an S-trace level, because S-trace level you will get each and every syscall itself, but here we are not getting that level. But Beyla can do it because end of the day it's an eBPF based program. It can do S-tracing inside it, but I think the current implementation does not know, or else I need to check if it has some certain parameter which can do collect the S-trace ones. Just to quickly check also. There should be some values here where we can actually set what level of data that we need to pull in actually. Yeah. Yeah. Okay. Yeah. Yeah. I think any other doubts? Thanks, Nick.
I think one thing also that we should highlight here, the OpenTelemetry is an open standard, and we say it vendor neutral, agnostic to any observability platforms, right? But
Yes.
still, I see, you know, like if there, for example, if you are using Neuralink or Dynatrace or any other observability platform, they support OpenTelemetry uh,
Mhm.
collector for sending the metrics, logs, and traces. But I
Yeah.
feel like I have seen often the dashboards or all the correlation capabilities that we get if we use their proprietary agents. Uh, we don't get such fluid experience if we use such agents. Like if you switch to OpenTelemetry agents, while we are on such platforms. So that
Yeah,
is
yeah.
one
B- That is one
downside.
crucial thing because for
Yeah,
even for New Relic, the way that they inject the agents is like in depth to the application, where it is actually getting you much more insight into like block level things like that. That those kind of data can go through OpenTelemetry standard, but it's depending upon the vendor side actually. But most of the open source tools, from a collection point of view, now is exposing OpenTelemetry like based metrics. So if you are using something like VLLM or any other kind of newer tools, so from a collection point itself, they are exposing as an OpenTelemetry format. So it's a format that is being adopted well. But when it comes to New Relic or other things, the collection done by those proprietary tools are on the greater side. Even as an example, like if you are doing Dynatrace, Dynatrace also does the eBPF based connectivity. It do auto instrumentation. It does that one, but the data that it pulls and the relationship it builds is much more better than the open source ones which we have there. Open source, you have all the data there. To be honest with you, it's just basically stitching together and getting a great dashboard insight out of it. Dynatrace does that in a very good manner where it can do auto injection and it can have the eBPF raise both the ones. Then, but it is actually merging all those things together and giving you much more insights. But yeah, it's a little bit
yeah,
lacking on the vendor side as well.
correct, correct. So,
Yeah.
and what is your take on Grafana Alloy?
Grafana Alloy is actually a good replacement for an agent side. So still, I will keep what you can say OpenTelemetry collector. I will only use the Alloy as a in an agent mode. So Alloy can collect the metrics as well as logs from the nodes. Then it will send to the collector because collector can do much more things. So it's basically in the old days, like not old days, like still we have it. So it's same as like you have the fluent bit as well as the fluent D as a collector itself. So Alloy can do all of these stuff. I think they are pushing for Alloy to be get there. I think Alloy in the latest releases of Alloy can act as a collector as well. So, but most of the deployments that right now we are doing, it's basically we are using Alloy for collecting logs as well as metrics from the nodes. Then we are actually sending to collector for doing the custom attribute injection, things like that. So collector is like a point where you do your what you can say policy plus a centralized way to manage it.
Yeah, but again, like Nikhil, like if the objective is to go vendor neutral or agnostic to any platform, so using Alloy might be an anti-pattern here, right?
Anti-pattern, yes. Collector, the OpenTelemetry collector, if you deploy it in daemon set mode, it can scrape your logs as well. You don't need a separate tool for scraping the logs actually. So logs also using OpenTelemetry, you can scrape it. But I think the metadata injection was the issue. So previous deployments that we have done is basically we tried to use the OpenTelemetry collector to scrape the metrics, but we still found there are certain limitations there. So we used Fluent Bit for collecting the logs. Then we were actually sending via OpenTelemetry collector, or for logs alone, we were directly sending to the target system because in the logs we can do the segregation from there. So it's from login side, I found it quite okay, but when it comes to a centralized place, there will be some kind of winter lock-in that we are facing there because end of the day we are stitching all these things together from an open source stack perspective. One of the good
Right.
ventral like open source stack that we have stitched was like Fluent Bit for collecting logs, OpenTelemetry collector with like a proper Prometheus plus auto instrumentation. On the target side, we had Tempo, the Grafana Mimir, then Grafana Loki, then like Coast plus certain other tools. But still, we were like still paying for certain tools. But the collector plus the exporter side was vendor neutral. So in tomorrow, if they decide to go to Dynatrace or anywhere from the collector side, we were able to switch in and change the platforms. Yeah.
And I have another question about take on the Signals or any other open source platform for observability. Like, what would be the best stack? Maybe Nikhil, if you can share.
Yeah, so I haven't much played with Signos, but it's basically like it's like ELK kind of where you're getting all the things together as a single product. if you don't have, because the maintaining all these tools together is actually a little bit tough, because you, like as you mentioned, like when you are having multiple tools, the amount of effort or engineering effort required is higher. So there is a cost plus. So if you are get starting, I will always suggest to go with some SaaS tools like New Relic or any other tool, or else even the cloud tools are fine. Then there will be a cost associated with it. So if your cost goes, so for the observability, if you are paying more than 50K USD per month, so that's a huge cost. With that cost, you can actually deploy a cluster, deploy an open source stack or any stack, and you can still manage to cover like 1 or 2 engineer salary. So there is a cost. If your cost is going to a level where it is too much, it will be cheaper to set up your own open source stack, and you can actually keep it like that one. Signals, like I think those kind of platforms will actually give you like all the things out of the box, so you can get started really quick, and you don't need uh, much things to be set it up there, because everything will be like click ops. Like you can actually get started really quick actually. Yeah.
In
The,
Signos is also using OpenTelemetry, right? So
yes.
even if we want to switch to a different platform tomorrow, you can easily switch. That is the a good thing about OpenTelemetry, right? So Signos
Yep.
is basically they are also focusing on OpenTelemetry. They are evangelizing it, and they are taking a lot of effort to make telemetry as a standard in the industry. Yeah,
Yes.
so I think getting started with the Signos, and maybe if you want to move to a different platform tomorrow, that would be easy. If you're thinking to start Signos for some clients or customers.
Yes.
Yeah.
The only thing which worries me about is basically the uh, when you're self-hosting it, it's basically your capacity planning. Basically, the way that storage and everything is handled is different. So one advantage of mostly the Grafana stack is basically the architecture of all these tools are somewhat similar. So if you're going microservice mode, they have their own compactors, their own like front-end courier, things like that. Architecture is pretty much safe, and you can actually dump all the logs to a GCS buckets or even a storage bucket, and you can store it for a very long time. Like in old times, like we used to, like even in case of Signos also, like sometimes if you go to Elastic way, because Elastic done a lot of contribution to open telemetry to make it as a standard. So in the newer open Elastic versions itself, they support open telemetry collectors. They have their own agents. Their own agents are like somewhat pretty good. So actually, I believe the all the open telemetry agents for the instrumentation is actually came from Elastic itself. So that also has all these platforms and everything together, where you should be able to do it. It's just basically the licensing and other side of things.
I think we're over the time, but still, if you guys have any questions, I think we can take it up for maybe next few more minutes. I think we will keep talking about these technologies, like when we get a stage, right, Nikhil?
Yeah, yeah. We do, like I think past 1 year it matured to a lot, because remember like when I did the implementation 1.5 years ago, like I was fighting with all the guys on the Slack group, in even in OpenTelemetry collector group plus Grafana group. I think for kubectl also, like I was like having some chats with them, like we were enforcing like this need to be in this certain format, then only like we should be able to like combine everything together. So when I'm looking at it now, most of those things are in place, and we were able to achieve a lot, and it's quite mature. Like I'm actually like I was surprised, like I was reading the documentation and everything. It's pretty much to a point where it's very mature. Even for OpenTelemetry auto instrumentation, Go was not there. Like a couple of months back when I was checking, Go was not there. Now I can see Go there actually. So it's getting to a
And
point where it's standard.
yeah, another thing that I observed, like if we want to keep everything together, like traces, logs, and metrics, that's when the platform cost is getting on the higher side. Like for example, if we want to use some vendor like New Relic or Dynatrace or yeah, Datadog, for example.
Yep.
So why I'm saying that, because the logs or traces that fluctuates, right? Like it depends on the
Yes,
traffic and many other parameters. But metrics is sort of constant for all the time. So
yes,
maybe at sometimes I have seen like customers tend to keep this metrics or some APM profiling sort of thing on the need basis, as you have well observed and recommended, right? So this profiling and stuff like traces, they will just enable it on the need basis, and metrics they may keep on this Datadog or this platforms uh, where they have to make the payments, right? And the logs and everything, they will just keep it in an open source or self-managed platform, right? That can fluctuate, and that doesn't fluctuate a lot of cost because they are managing it, right? So I have seen
yes.
that pattern also. So what is your opinion on that?
Yeah, so the thing with the metrics is basically the data volume for metrics will only increase if you change your scraping interval, or else if you're adding like more metrics or more resources, basically services. Like if you're adding Kubernetes, not then only it will change. And like to be honest with you, like from a metric side of things, it's basically a time like TSDB, and it can store more efficiently there, and the data point also is very less. But when it comes to storage for logs as well as I think span like traces also to a level you can do normalizing, but at the end of the day, it's a text raw text one that can impact a lot, and it can actually, as you mentioned, like when the more traffic is coming, there will be more logs generated, more like basically traces generated. But metrics is same because you are every 5 seconds you are getting the current value, so the numbers are same. So the volume will not increase. It's just the number inside that data only changes. So that's fine. So over there, the one of the most recommendation is basically do a sampling. Don't collect everything. So the moment that you are insisting on collecting everything, that's where the cost will go like skyrocketing. So for logs, make sure that you are doing proper filtering. Don't collect all these debug info logs. Just only collect the error logs and do a proper filtering. You don't need like the one of the most example is like if I am asking any engineers to collect the logs from it from a Kubernetes, they will directly go, they will collect all the Kubernetes metrics and they will send to me, like send to the target system. That will include the ingress or the gateway logs, where each and every request is getting logged there. Like you don't need those logs. You are just like collecting those namespaces logs for unwanted one. Even for rancher environments, you don't need most of the time you don't need the logs from the cattle namespaces where the core components are running and there are a lot of log volumes there. So once you filter it out only to application, you can actually reduce the chunk there. Then filter from like I don't need info logs. So those are need to be done from the application side. If they are doing a proper log level, just reduce it. Traces, don't trace everything. Do a sampling. So if you do a sampling, right, like from a collector side itself, if you are doing a sampling there, you can reduce the trace volume. Then if you found, okay, in the 100 ones it's getting increased, then if you want to really go, then like reduce your sampling rate or increase your sampling rate according to that one. So my recommendation is don't collect everything. Then the other one is like I will try to, if I'm in cloud, I will try to keep the logs in the cloud logging itself. So if it's in AWS or GCP or in Azure, I will try to use their logging solution more and do a tracing there itself, because then I don't need to manage it, because as you also know, like managing a log system, if it's after a couple of TBs, it's becoming to a point where like you need to have a really good engineers to manage it there. So it's sometimes it's like from a headache perspective, it's like you are offloading that to the cloud, you are paying more over there, but it sometimes it will be cheaper than managing your own solution. But yes, as you mentioned, like if I'm using traces, I can keep it in native system, and if I'm having an open source stack, so if I'm investing in a big ELK cluster or a big low-key based environment, I can offload the logs to there. They will be do using it. I have seen customers using it like in this, especially in UA region, like the customers are invested on ELK. They have a big ELK cluster where they can store like petabyte of data. Then for from cloud, they are like directly pushing all things to ELK and storing it there. But metrics as well as traces, they are sending to New Relic or any other solutions. Then they will add like in Grafana data source, they will add the data source and just check it out from there.
Okay, I think maybe we can probably wind up for today.
Yeah.
All right. So yeah, thanks for Nikhil for putting up this session together and with the demo and everything. Like I think this session, everyone have like better, like everyone might have got better understanding on how open telemetry, what is open telemetry, right? And how the auto instrumentation work, and the open telemetry versus Beyla, how they differ. I think all of us have a better understanding on OpenTelemetry, how to write a better pipeline and all that. So yeah, thanks for putting up this together. Thanks for spending time with us today. So thanks, Nikhil, for that, and thanks for everyone who have joined